After this lesson, students should be able to add polynomials of any degree and of any length. For this purpose, we will adopt a three-step strategy to add polynomials. But before we start adding polynomials and solve questions, let's first understand what are the like terms. The like terms, as it is indicated in the prerequisites, for the two terms to be called like terms, variables must be same in both the terms and the exponents of those variables must be same as well. So let's solve a question. Example, 2m plus 1 plus 1 is one polynomial and 3m plus 9 is another polynomial. If we want to add them up, we can adopt a strategy just like the one we already indicated, that group the like terms. So where is the like term is, if any, for 2m? This 2m and 3m, they are like term because both terms have the same variable m and the exponent of that variable is also same. So if we want to find the sum 2m plus 1 plus 3m plus 9, if we want to find their sum, then 2m plus 3m, we have grouped them together and the constant terms are like each other, therefore we can group them together as well, 1 plus 9. So once we have grouped them, we can find the sum, that is 2m plus 3m will be how many m's? That will be 5m. Remember that the answer or the sum carries the same power as was the power of the two participating terms. Plus 1 plus 9 would be 10. So this is how we can add. And now there is one more example, and it says add 3x square plus 4x plus 1 and 9x minus 3x square plus 21. If we want to find the sum, we should write it like this, sum. Now the first polynomial, that is a polynomial of degree 2 with 3 terms, and the second one as well is a polynomial of degree 2 with 3 terms. Therefore we are going to find their sum. This is 3x square plus 4x plus 1 and then plus 9x minus 3x square plus 21. Now let's start with the first term of the first polynomial, 3x square. Is there any other term which involves only x square? There is this term. Now we can surely we can take a look on both the variables and their exponents and classify them together because they are like terms, 3x square minus 3x square. And now take a look on the next term, which is 4x. Is there any other term in both the polynomials which involves only x? That is 9x. Now these terms are like terms because the variable x is same and exponents of x is also same. We group them together. That would be 4x and plus 9x, and what is left behind is plus 1, the constant term here and the constant term here. Both are constant terms, so they are like terms. It's 21. And now 3x square minus 3x square. It's like 9 take away 9 will give us 0. 3x square minus 3x square will give us 0. So plus 4x plus 9x will give us 13x, and 21 plus 1 will give us 22. Therefore, we have the answer 13x plus 22. Let's do another question. And in this question, now we have a px1 polynomial is equal to 11x square minus 3x plus 18, and another polynomial which is qx, that is 9x cube minus 3x plus 11. Find px plus qx. It means the sum. Sometime the words are performed by the symbol which is used, which is here the plus sign. So px plus qx means the sum of the two polynomials. So we start with the solution, and px plus qx is equal to, what is the value of px? 11x square minus 3x plus 18, and plus the second polynomial qx, that is 9x cube minus 3x plus 11. Now let's start with the highest degree term. The highest degree term is 9x cube. So let's write it down. Is there another like term, like is there another term which involves x cube? There is no other term, so let's write this down and then move on to the next term, which is square, 11x square. Is there another term which involves x square? No, there is no other term which involves x square, so we write this down and then we move on to the next one, which is minus 3x. Is there another term which involves x only? Yes, there is one, which is this. So let's write them together, minus 3x, and this is constant. Is there another constant term? Yes, there is one, which is called 11, and plus 18 plus 11, and this would give us 9x cube plus 11x square minus 3x, and minus 3x will give us minus 6x, because two negative signs always add up, and plus 18 and plus 11 would give us 29. So this was the sum of the two polynomials, and if we do couple of more questions, then there will be another example. Find the sum of minus 2x square plus 3x cube plus 5x minus 1 and 2x4 plus 5x square plus 3. So again, these are the this is a first polynomial is a polynomial of degree 3 with 4 terms, and the second one is a polynomial of degree 4 with 3 terms. If we want to add them up, we can certainly add them. Solution here, and let's group them together with starting with the highest degree. If we have highest degree in both of the polynomial is 2x4 there, and there is no other term which involves x4, so we are fine. Let's move to x cube. Where is x cube? Is right here. And is there any other term which involves x cube? No, there is none. So plus 3x cube. And now let's move on to x square. Is there any other term which involves x square other than minus 2x and 5x square? Both terms involve x square. So let's group them together. Plus 5x square minus 2x square. And is there another terms? So this is 5x, and there is no other term which involves x only. So 5x will be left alone, and then there is a constant term that is plus 3 here and minus 1 here. They can be written together in a group. So here we have two groups. One group is this and one is a constant. We can simplify them. So this would be 2x4 plus 3x cube and 5x square minus 2x square. That will give us plus 3x square and plus 5x, and plus 3 minus 1 will give us 2. So this is the sum of those polynomials. And now the last question. Example here. Simplify simplify 2x plus 3y plus z plus 11xy plus 3x plus 2y plus z plus 1. And here, starting with the extreme left, 2x. Is there any other term which involves x only? Yes, this is. So this is all about identification of like terms. So here is 2x, there is 3x. So we can group them together, 2x plus 3x. So 3y, is there any other term which involves y only? This term is there. So plus 3y and plus 2y, they can be grouped together. And here is a z. Is there any other z? There is z here. So they can be written together. Z plus z, and then plus 11xy. Is there any other term which involves xy? The product of x and y. No. So 11xy will be written as such, and there is only one constant term, plus 1, and we are done. Now let's perform the indicated operations. 2x plus 3x will become 5x, plus 3y plus 2y will become 5y, and plus z, and z will become 2z, plus 11xy plus 1. So this is the sum of the polynomials. But remember, this is all about identification of like terms and then group the like terms together and rearrange and write the answer.